Okay, so this is Monday. I think it's October 3rd. Anyway, we're going to be working on Unit 1.7 today for sure. And we're looking to see if there's definitely some problems from the homework that we could go over. And so the first one that was mentioned was something like this. So let's say there were 4 digits and then 3 digits and you had to multiply them. I'd be inclined to put the 4 digit on top and then the 347 here, and you've got to multiply it. Okay. So what I was showing you last time is that what you need to do is start with 7 times that and get that one done. So 7 times 0 is 0. And if you can kind of ignore that, let me see if I can put something in there so you don't have to look at. So 7 times 0 is 0. 7 times 6 is 42, carry of 4. 7 times 3, 21, and 4 is 25. 2 left over, 25. And then 7 times 1 is 7, and 2 is 9. Now, if somehow I make a mistake, which I can do because I'm thinking of 4 things at once, just let me know right away. Don't, feel like it's improper to ask. Just make me look at it again. Now, when I deal with the 4, so the 7's done. When I deal with the 4, it's in this position, so the first answer has to go 1 over. And so try to just see the 4 and ignore the 3 and the 7. So 4 times 0 would be 0. 4 times 6 is 24, 2 carried. 4 times 3 is 12, and 2 is 14, carry a 1. And then 4 times 1 is 4, and 1 is 5. So if you had multiplied 4 times this, you would have gotten this number. It's just shifted 1 position over. And the last row, you've got to deal with a 3. And instead of being in this position, it's got to be 3rd over. So what it amounts to is it's 3 times that. So 3 times 0 is 0. 3 times 6 is 18, carry a 1. 3 times 3 is 9, and the 1 is 10, carry 1. And then 3 times 1 is 3, and 1 is 4. As you can see, if things are not lined up the way they should be, it gets all skewed up. And so then the 0 comes down. This would be a 2. This is adding. This would be a 9. I can add it either way. This is 12 and 9 makes 21. Carry a 2. And I'm always carrying just because I prefer to, but you don't have to. And then 5 and the 2 carried would be 7. And then the 4 is there. So that's your answer. What a mess, huh? You like the mess? Hopefully you don't have to do too many of these, but the key is sloppiness will not get you anywhere. You've got to stay neat and in rows, because with adding, everything has to be in the correct column. What do you say? Anybody else have something along that line? I sometimes look at problems out of the book, not that they're any different from problems online. But we will definitely look at those in a little bit. Anybody have another question? And if you would, jot it down on your paper so that it's handy at the start of class. We can do your exact problem, because everybody has a variation of the same problem. So we might as well do your exact problem, and then you can kind of see where it went wrong.
We're talking about this last week's assignments, right? Not 1.7, right?
Not 1.7 yet. I prefer to just do up to 1.6, but we're going to do 1.7 in a second.
Sure, got it.
Anybody have something?
I got it, yes. It's just I'm a little dyslexic, so I see things different sometimes.
Oh, yeah. No, I know that's a problem, and just, you just have to find a way around it. I literally grew up with a reading disability. So it didn't ruin my life, but it definitely added to the problems. And so people see things differently. And so you just, you find a way around it. And so I only bring that up just because, I mean, everybody's fighting something. And so we just work with it the best we can. So, okay, anybody, anything else? Now, don't hesitate to ask. So what I wanted to do is, this is 1.7. I'm going to start that for now. And then if there's time, what I'll do is look at some of the review questions from this chapter and see if we're missing anything. So this was about exponents. And so when you start multiplying, and you keep multiplying the same number over and over again. So this is 5 times 5 times 5. As an exponent, it would be 5 to the third power. And so this is just a shorthand way to say the exact same thing. Many times when it's something like this, they want you to actually compute it and come up with an answer. So again, remember, with 3 numbers, you would multiply 2 of them. 5 times 5 is 25. And 25 times 5 happens to be 125. So that's how it would land if you went ahead with it. If they asked for exponential form, they wanted this. They wanted to see what it looked like as an exponent. If they actually wanted the value, then it would have been 125. Now, when you have this, the number that's repeated is called the base. And so that's the one that's going to be over and over again. This, of course, is the exponent. And so what we'll learn is exponents can be, you could have this, you could have 5 to the first, which would tell you, well, you only have 1. And so the result would be 5. 5 to the second power can also be said as 5 times 5, but we also sometimes call it 5 squared. So the second power is called squared, 5 squared. And so we'll see where that would square units, like square feet, square yards and such. So we say 5 squared or 5 to the second power. And of course, this then would be 25. The reason I started this is because this one also has a nickname. Although it's 3 5s, it's also 5 cubed. And so I'm likely to say 5 cubed, or I could, for this, or I could say 5 squared for this, and it still means 5 to the third power. And so we're talking 3 5s multiplied, which again is 125. Okay. Now, the only 2 that have nicknames, and I'm calling the square and the cube nicknames, are these 2, to the second power and to the third power. Where did this come from? Well, if you had something, a unit that's, let's say, 5 inches. In geometry, as we were looking at this, when it's 5 units, and this is a square, this would be 5 units. And so in area, it's 5 times 5, which is 25 square inches. So this is connecting to the geometry, the square here. But what I want you to show you is what happens if you go, this is two-dimensional. There's a length and there's a width, 2 dimensions. So it's flat. But if I went and did this, and I'm drawing this for you so that you can see it visually. This is now 3 dimensions. And so if this was 5 length and 5 width and 5 height, this would be 5 cubed. And so 5 cubed is literally, it's relating to the cube. So when it's all the same measurement, it's 5 and 5 and 5, that's where the cube came in, 5 cubed, whereas this was 5 squared. Is that okay? So that's what I want you to see. They nicknamed him. Now, 4th dimension is hard to imagine, although in mathematics, we think in multiple dimensions. But we just say, if it was one more, we would just say 5 to the 4th power. Is that okay? So only the 2nd and the 3rd have nicknames. And so I just want you to be aware of that because I'll use it both ways. It's somehow easier to say 5 cubed than to say 5 to the 3rd power. See what I'm saying? That laziness bit I talked to you about, you know what I'm talking? So that what's a simple way to say it? 5 cubed. And so that's why they do it, because they get tired of all those words. They like numbers, you see? Okay. Now, there's problems that involve adding, subtracting, multiply, dividing, and also doing squares or cubes or powers. And so this is the first one. What's the answer to this? Somebody can just turn on their mic and tell me.
Is that 15?
So this is a plus, and this is a subtract.
Oh,
I think
30?
I need another.
No.
I think you're trying to multiply, maybe.
Oh, yeah.
It's 4, right?
4.
Oh,
Anybody else have an answer? I want to collect a couple of answers if you think you have a different answer. What?
11.
Okay. I also heard a couple of ones where we're multiplying, but multiplying is not what we're doing here.
2.
So I've got at least 2 answers, you know what I mean? Now, this is what I ask you. Does this little problem have 2 different answers?
I would say no.
You said both. The answer is there's only one answer. And the only
It's
way,
only-
the only way for us to get one answer is to agree to a list of what goes first, what goes second, what goes third. And what that list will be is called order of operations. Now, adding is an operation, so is subtracting, multiplying, all the different things. These are mathematical operations, and we want to agree to what's needs to be done. It turns out, I'm going to make you a list in a minute, but it turns out adding and subtracting are of equal weight. And they're typically done dead last, believe it or not. And so when you have 2 things of the same level, you just go left to right. So you would start here and you would say this much is 5 plus 2 is 7. So that part's done. And then at this point, you would subtract your 3. And finally, you would come up with this answer. Okay? Now, I'm going to keep upping the ante. And I'm trying to trick you, by the way. So just give me some answers to this one. Anybody have an answer?
6.
6? Anybody have something different? I don't know who's answering, so just answer. Anybody have something?
I agree with the 6.
You agree with the 6. Okay. What I tried to do is write these two kind of close to each other, so you would think maybe they go together. And some people are thinking that adding is more important than subtracting. But what I'm here to tell you is they're equal. And so when they're equal, you might have been tempted to add these together, thinking adding is more important, but it's not. It's again left to right. So this 5 subtract 2 is 3. 3 plus 3 is 6. That was correct. Okay. Now, this is divide, and this is multiply. So what answers do you have for me?
25.
There's one answer. Anybody have
I got-
something else?
I agree with 25.
You agree with 25? I think you're getting what I'm trying to say
got
about
one.
this. Some people think that multiply is far better than divide.
Mm,
And I'll eventually tell you why. But they're not, they're on equal terms. And so in that case, we're again into the left to right rule. And so this is 10 divided by 2 is 5. 5 times 5 is 25. Okay. But weren't you did you see that 10 there? Was that a temptation there? It typically is. And I set this up to tempt you that way, thinking that multiply was better than divide, but they're equal. Now, this one has parentheses. And parentheses call your attention to it and ask you to do that first. Okay? So even though subtract, and you'll see in when I make the list, is dead last. When you
My
put
answer,
what is your answer?
10.
Okay, I like it. So even though subtraction is dead last, typically, when you put parentheses around it, it changes it. They're the only language I studied in high school and college was Spanish. And what I learned from that was that you could predict how to say the word unless there was an accent mark that told you to say it slightly differently. And so the parentheses are just the same kind of thing. They're forcing you to do something that you might not have ordinarily done. And so this is 6 take away 4 is 2. The 2 is now in the parentheses still. There's a 5 out here. Then this number and this number, you have to assume with the parentheses or with that symbol, nothing at all, you have to take it as multiply. How's that? Now I want to change this problem. 5 times 6 subtract 4. Okay, that's similar to what we did, but it's not the same. The parentheses is around the 6, and in this case, it's used to mean multiply. So this is 5 times 6. So you could stare at this 6 and say, oh, what a nice 6. But there's nothing to do but say, well, there you are, that's a 6. And so you interpret this as multiply. Now the question for us is multiply more important than subtract?
yes,
It is. And so multiply dominates over subtract And so what I'm forced to do is this first, which is 30, and then that becomes a 30, subtract 4, this is called 26. Okay, so what we've learned so far is that adding and subtracting are equal, multiplying and dividing are equal. And if you have multiply and subtract, multiply dominates. So see, multiply is higher up on the list. In fact, the highest thing on the list is parentheses. And so anybody have any, somebody mentioned they might have questions from 1.7. And so I'm just going to pull a couple of problems, but anybody have something?
I was wondering why, like, why is it that 0, like, so for instance, they had an example of 10 to the power of 0.
Oh, okay,
Like, why is it 1? Like, I understand that
I got it.
that it is, but why?
Okay, you've accepted it, but let me tell you about the 0 power. Thank you for bringing that up. So what I'm going to try is an example like this. Now, this is division, and this is 5 to the 4th, 1, 2, 3, 4, right? And this is 5 to the 3rd. I'm going to get there, so I don't. And if you simplified it, you would cancel 5 for a 5 again and again. And what you're left with is 5 to the 1st, or better known as 5. Does this sort of work for you, even though we haven't done much with this? Can you see that this would work?
Yeah.
Now, if I had 5 to the 3rd divided by 5 to the 2nd, what we'll eventually see is that if there were 3 5s here and 2 here, we'd be left with 1. Right?
Right.
1, 2, 3, 1, 2. We'd be left with 1. And the shorthand way to see that is 3 take away 2 is 1. 4 take away 3 is 1. And so then, of course, it's sort of an unwritten rule that you write the answer in the simplest possible version, and 5 is better than 5 to the 1st, although they're the same thing. Here's where I'm at. If I had 5 to the 3rd and I had 5 to the 3rd in division, and I use the subtract rule, right? That would be 5 to the 0. Okay.
Oh yeah, because you're dividing it. So okay.
Now, 5 to the 0, I need to say, what's the simplest answer to that? Is it 5? What is it? Well, here's what I'm going to do. I'm going to do it the long way. 5, 2, 3, 1, 2, 3. That's what it looks like. So you cancel that out and it's a 1, cancel that out, it's a 1. And 1 times 1 times 1 is 1. So I did it with the subtraction rule, which I think makes sense. We'll do more, of course. But I did it with the subtraction rule and I got that. I did it out the long way, or I could have actually done it like this. 5 times 5 is 25, times 5 is 125. And this is also 125. And so those two together make 1. So no matter how you shake it, I did it out the long way and I got 1. And I did it out with this thing that I just showed you, which is 5 to the 0. Now, what I'm asking is, could this same problem have 2 different answers?
I'm gonna go with no.
Good job. It's a no. If we in mathematics have a problem that has a whole handful of answers, we are in such trouble. Can you appreciate that? It's bad enough if there's one answer that you're searching for, but if there's a whole handful of answers, we don't have a prayer.
Isn't that
Got
the
it?
premise? Isn't that the premise, right? Like that's the whole.
Yes, and so what I'm saying is the only way this is gonna hold up, and we're gonna have a fighting chance if this is equal to that.
I like that answer.
Do you like it? I've also, it was pretty good.
Yeah.
So this would work no matter what number we had used. 4 to the second over 4 to the second. See, it didn't matter what the base was. The subtracting, this would be 4 to the 0, but we know this is 16 and so is this, and that's 1. So any number, well, almost any number to the 0 power is 1. There is one exception. This one is undefined because the way this problem would have had to work is, let's say, had 0 to the 4th divided by 0 to the 4th would have been 0 to the 0. What is that? Well, the problem was the problem itself was no good. You can't divide by 0. So then this is this doesn't have an answer. This is undefined. And I don't think this book actually asked for this problem. 0 to the 0 power, they just make a little note that any number except 0 raised to the 0 power is 1. But this is one thing that could have happened that applies to what we've been doing. I don't think it's in our book.
Undefined is like infinity, right? It's like similar to it.
He's
Like
trying to go to infinity, and good luck is what I say. Good luck. We can talk about it, we can imagine it, we can be happy about it, we can't do it. Because you can always add one more no matter how high you get. So it's a concept. So does that work for you, the 0 power?
I love it. I love undefined as well. I love
Okay.
both of those things.
What else? All right, so here we go. So what I was trying to do, and again, oh, here's a problem for us. This is out of my book, but who cares? Sooner or later, I'll make a list, but I think you've almost got enough here to make this work. What would be first?
The parentheses.
Absolutely,
Multiply.
parentheses dominate. It's sort of like whatever rule was out there, parentheses overrides. And so this is 5 take away 3 is 2. I'm going to put that in parentheses so you can see that's how that went. The 2 in front of it is still there, and the 8. Now don't be subtracting next, because subtraction in general is dead last. So what about these two? What's the operation?
Multiply.
That's a multiply. And so we've got to do that next. And see, if we don't agree to do this, then everybody's going to have 6 different answers and we'll never have a right answer. Well, we might, but we'll have too many answers. Typically, when I do these problems, I get 4 or 5 answers. And they can't all be right. So 2 times 2 is, this is 4, this is 8, and that's subtract. So a mess became less of a mess, became less of a mess, became 4. How do you like it? So what do people do by mistake? Oh, I'll tell you, because I've seen it 100 million times. They see 8 take away 2 and they say 6, and they're wrong from the beginning. They've got to follow the rules.
I would have done it that way until today. Like that
Okay.
is news to me.
Yeah, I'm gonna make you a beautiful little list, and then ooh. Okay. Now, here's another good one. This is having to do, we've talked about parentheses and we've talked about exponents and so on. My first question here is, you see this square and powers are high on the list. The square or the second power applies to which number? That's what I want to know. Does it apply to the 8? Does it apply to the 5? Does it apply to both?
It applies to the 5.
Only the 5. So this 8 is good as gone as far as I'm concerned for right now. The 5 is the part that's raised to the second power. And so if you need to do a little work on the side like this, 5 squared is 25. Just do the scribbling, but keep this neat so you have a fighting chance to see this through. So 5 squared is 25. This is then 8. And I need to put some kind of symbol here to show it's multiply. We talked about this last time. So you could put that in parentheses. You could put a dot there. It doesn't matter, but you've got to do something to separate those out. I'm going to deal with that in a minute. Remember, this subtract is probably last, unless there's parentheses. Over here, I've got 3 cubed. And don't say that's 9 or something. That's a mistake. 3 cubed is 3 times 3 times 3. And so that's 9. And 9 times 3 is 27. This was a book problem out of the book, so I'm just going to deal with it. The number's a little high. And so 3 cubed is 27. That would still have to be multiplied by 7. So here I have multiply, subtract, multiply. The multiplies have to be done next. The subtraction is dead last. So I'm going to do 25 times 8, and I can scribble it on the side if I want to. 8 times 5 is 40. Carry a 4. 8 times 2 is 16, and 4 is 20. So this times this. In fact, if you can relate this to something you know, for instance, if you've ever had to work in a store and you had to deal with money a lot, 8 quarters. You know what I'm saying? Money works. 8 quarters, $4, 4, and then another 4 would be $2. Lazy. Okay. Then these two need to be multiplied, and I'm going to scribble it on the side. 7 times 7 is 49. Carry a 4. This much is 14, and 4 is 18. So this is 189. So I've boiled this down, 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 down. And why do we keep writing down and down and down? Because it's the safest thing to do when we do it in algebra as well, so that you don't make mistakes because you keep writing more and more and more over there. This way you have the best chance of not copying something wrong. So 200 take away 189. Anybody have it? Yeah.
11.
Okay. 11 it is. How's that? Okay, so the numbers were bigger. We had to do some multiplying and all, but the rules were in place. Now I'm going to make you a list. And so this is order of operations. Number 1, parentheses. Now I'm going to look at their list because I always do mine a little differently. So parentheses, they also mentioned above and below a fraction line. I'll show you what that means in a minute, so that you simplify what's above the fraction line and what's below it before you actually divide. So this is parentheses in general. I may add to that. The second order of list is exponents. So this is the squaring and so on. And it turns out that everything you do in math, you can undo. And so there's a way to undo squaring, like square root, we'll see that eventually. And there's a way to undo anything that you can actually do. Like if you add, you can undo it by subtract. If you multiply, you can undo it by divide, and so on. So exponents are second. Third on our list is multiply and divide. They are equal. And so if they're both in the same problem, we just go left to right. So if divide was first, we would do divide, and so on. And we saw one problem like that already. And last on our list is adding and subtracting. And again, if they're in the same problem, and that's all we have left is adding and subtracting, the rule would say, go left to right. Okay, now, there's two ways people learn to memorize this. This was one way that people learned. We called it PEMDAS, parentheses, exponents, multiply, divide, add, and subtract. The problem with this memory device is it looks like multiply is better than divide. And we know it's the equal. Adding and subtracting, it looks like adding is more important than subtracting, which is not the case. They're equal. And so this is a memory device, but you have to be careful that you keep in mind that multiply and divide are on equal terms. They're on the same level. And so don't be tricked about that. The other one that people used to teach, and I think everybody looks to me, the ones that are showing their face, a lot younger than I am. Please excuse my dear Aunt Sally was the memory device that they used to teach. Please excuse my dear Aunt Sally. That's how they taught it. But again, that has the problem because my dear looks like multiply beats divide, and we know better. So I like my list better than these two memory devices, but if you learned it, you can just adapt this little thing to make you happy, okay? So let's see what else I've got. Let me see if I can find anything that looks worthwhile. 5 plus 3 times 11 minus 7. So we did one like this. And so now you have your perfect list. And your perfect list says parentheses rules, correct? And so you would have to do this first, although we did it before. So 11 take away 7 is 4. And I would write it below that, keep it in parentheses so you can see that became that. The 3 is there, the plus is there, the 5 is there. I'm now left with adding and multiplying. And when I look at my list, the adding is last and the multiply is up ahead of it. And so I would have to multiply first. So this is the 12, this is a plus. When I'm down to just one thing, I just do that one thing and I'm done. And so my final result is 17. How's that? Any question? I wanted to show you above and below the fraction line. So here it goes, 20 plus 6, parentheses, 2 over 11, take away 7. Now, This rule about the first level, above and below the fraction line, basically what it's saying is this top of the fraction line is a group and this bottom is a group. And so you will be doing simplifying the top and then simplifying the bottom before you ever do this. And this fraction line means divide. So the divide will be last in this case. It's as if there was parentheses around each piece, the numerator and the denominator. So what do you do with 20 plus 6 times 2?
Multiply the 6 and the 2 first.
Okay, good job. So this is 20 plus the 12, right? And you know how that's going to turn out. 20 and 12 would be
32.
32. This is just a simple one. 11 take away 7 is
4.
4, and that's 4. So the division, this reads 32 divided by 4. The division is last in these type problems. And so 32 divided by 4 would be then 8. Right? Because division and multiplication are tied at the hip. So 4 times 8 is 32. 32 divided by 4 is 8. You need one to do the other. What do you say? Okay. Now, toward the end of this section, they had a few problems like this. In words, and this is a review. The sum of 8 times 5 and 5 times 4. I don't know. We'll do our best. When you have a word description and you've got to turn it into, translate it into an equivalent mathematical expression, this is English, that's what's wrong with it. We like math. You got it? Just say yes, you do. I love math. And so the thing here is the sum. This is the first piece of this is what dominates. And so it's a sum. And so it's really going to be two things added together. Now, the first is 8 times 5. And so how would I write 8 times 5?
Multiply.
Yes, and so which symbol do you want to use this time?
Parentheses.
Okay, 8 parentheses 5. Is that good?
Yeah.
That's one. And the second one is what?
5.
Times
4 in parentheses.
4, like that, or dot. You can use a dot. I don't care. I kind of like parentheses, but it doesn't matter. So you could get scrambled in this. I really believe you could. But the trick to these is to see what comes out of the gate first. And what comes out of the gate first is this word, the sum. So it's really about a sum of two different things. And the first one was 8 times 5, and the second one was 5 times 4. They really wanted this. This was the answer that they were looking for.
Mm.
Let me write another one down, and then the difference, I don't know if you remember that word, but we're going to see it again. The difference of 10 times 5 and 6 times 2. That's what's out of the gate first. It's a horse race. It's a difference. And so it's a subtract. And so the first one, the first part of this problem, 10 times 5, and you told me how to do that, so I'm just going to do it again. The second part of the subtract problem is this. But what dominated was difference. How's that? Otherwise, you're gonna get all snarled. Ah, here's one for you. Love it. Twice the sum of 10 and 3. Twice. This is what matters. This is about twice, which is doubling something.
So it would be 10, the 3 in parentheses to the second power.
No, there's no powers here at all, because what does sum mean?
Addition. So 10 plus 3.
Adding,
It's adding. Sum is adding. And so you could look at this. This is another part of the problem. You might work this first, but this is actually what matters. The sum of 10 and 3 is this. That's sum. Sum is add. 10 and 3, 10 plus 3. But what, and I put it in parentheses because what this problem is about is doubling whatever this is. How do you double it? What number goes here? What?
multiply by 2.
Yeah. Now, you could have been tempted to do this. Then you've gone twice the 10, but you haven't gone twice the 3.
Mm.
See, this is not it. So it's twice, so it's 2 times whatever this is. And what this is the sum of 10 and 3. I put it in parentheses so that the 2 is multiplied to both these numbers, the final sum. Okay, so the key thing is twice. And so the 2 belongs on the outside. I use parentheses to put this thing, and that forces this to be both 2 times that and 2 times that because of the distributive property.
I have a question.
Yeah, go ahead.
So it's kind of like my 10 to the 0 question. Why? So why couldn't I write that as 10 plus 3 equal times 2? I understand that we have the rule of like doing the multiplication first.
Tell me
But-
what you wanted to write.
Like, let's write it out as 10 plus 3 times 2. And we know the rule is that we do the, if we write it that way, the rule is to do the multiplication first. But why is it that we can't just like, why do we have to do it that way? Why can't we just say it that we just write it all from left to right,
Okay.
answer it all left to right?
The problem, I mean, this is good, you're thinking, but you wouldn't be allowed to add first. If you wrote it like this, you wouldn't be allowed to, this would be the last thing you would do.
Mhm.
Now, if you put parentheses around that, then you would be forced to adding, because it's twice the sum. So if you did it like that, if everybody understood that you were going to add the numbers first, get the sum, and then double it, which is twice, that would be okay. But in this particular scenario, you would be forced to only multiply the 3 times 2.
Mhm.
And then the 10 wouldn't get doubled.
Yeah, I guess I get that we have the rule there. I'm just curious as to where that rule came from, like what got it to that point. Does that make sense? Like,
Where did the rule come from? Good Lord, I
Yeah.
don't know.
oh sure, I mean, I guess like where is it in the equation that it where is it in math where that rule had to come up? They're like, okay, we need it that way so that we don't get this thing wrong.
I
Like-
think instead of thinking of it as getting wrong, it's like if we have 20 people in this class, we could have 20 different answers
Mhm.
to this problem. I mean, I could make it complicated enough that we'd get 20 answers.
Right, okay.
So in a sense, we have to have some rule that makes it possible for us to agree. So that we're all doing the same thing. Somebody had their hand up. Was it?
Yeah, you say we're doubling the 10. And I don't get how the 10 is getting doubled if we're gonna add 10 plus 3 first. Because that's
Well, this is no
30.
good. That's what we were just discussing. Writing it like this would not be right. Because like you said, you're gonna double the 3, but not the 10. So in order to, it's 2 times the sum. So you're really forcing yourself to do the adding first. The 10 and 3. So if you actually did this of course would be 13. And this would be 2.
Times the 2.
This would be 26. Any other approach, this approach would have worked if you had added first and then multiplied by 2. But I think it makes more sense to put the 2 forward, but both of them would get you 26. But we can't be happy with everybody having a different answer because people have struggled with math. And if there were 10 answers for each problem, where would you be? You'd be up the creek without your paddle. It's where you would be.
Correct, but there are many answers to this problem. If you do
No,
it
there's
different
a
ways.
single answer. And so in a sense, the list basically puts everybody on the same page. Everybody understands the list and everybody follows the list. And then we'll all have the same answer. And believe me, when you turn in an answer and you don't follow the list, they're going to mark it wrong. I mean, that's, if you want to get down to practical terms, you want them to mark you right. But in a
Yes.
sense, you're agreeing to the list.
Correct.
What do you think? So I'm having people drop out. I think that's so interesting. I can hear when somebody leaves the meeting. Maybe you guys can't.
I don't know.
I've got things in the chat. I wanted to go and see what people are saying. Okay.
I have another question.
You still have PEM? Do you still use PEM? Somebody asked about PEMDAS, and it really works as long as you understand that multiply and divide are equal terms, and you go left to right, and then add and subtract. So PEMDAS is still good. Okay, so people are talking. Oh, they're giving me answers.
Margaret,
Yeah,
and the homework that we had last week,
yes.
I think in 1.5 or 1.6, I got the right answers and the computer says that I had the wrong answers.
Okay, well, the only way to do that is we can look at those problems, individually. And it could be a simple matter of not giving it the answer the way they wanted it. In other words, you had it right, but then you didn't give it to them as they wanted it. I don't know, but I'll have to look at your individual work.
Cool. But you check on those?
Yeah, I can do that as soon as we finish the class. We can go in and look. But that's the kind of thing that you would write down on your paper as you're doing your work, so that we can, or we could just do it. If you knew the exact problem, then we could talk about what's the exact answer.
Well, I have to take a look because I print them.
Okay. Yeah, no, that's fine. Anybody else?
I did find that problem that I said was, I found my homework and I was able to find that problem that I said was
Okay.
worded.
You tell me what it was?
Yeah, so it looks like it is on 1.1. It's the first, it was the first one, 1.1, and it was the second question.
Yeah.
Said the number 619 is written as blank, or is written blank form, but is written in blank form.
Yeah, what were
And-
your choices? That's sort of like normal standard form. What word did they use?
So the like you had two words. You could say it was an expanded or condensed, but the way that it's phrased, it says the number 619 is written in blank form, but is written in blank form.
Ye- So bottom line is 619 is condensed, if that was one of your choices. Expanded, let me go back to this.
Oh, okay. I see how I got it wrong. Okay.
Expanded would be 600 plus 10 plus 9. That would be expanded. So you're
Oh.
calling what each one stands for?
Right. Okay, so the way I was reading it, I'm like, but it's written as 619. So they're both condensed in my mind. So
Okay.
does that make sense how I was reading it incorrectly?
Yeah, and I mean, they
Okay.
could have written it as words too, 619. I mean,
Right.
that's in word, in the word, as a word. And, you know.
I still think they phrased it incorrectly.
Okay. Well,
But thank you.
maybe,
Yeah.
you know, like I said, English is not my thing either. So let me have math.
Oh.
I don't know what happened. It's technology. I took classes in Massachusetts. Almost everybody in the class was from a different country. It was so interesting. And the person teaching was probably from somewhere else too. They put the problem on the board and everybody understood it because math is a language. So everybody was happy as can be until we went into English. And as long as we stayed in math, everybody could follow it because it made good sense. You know what I'm saying? So in some ways, that's what we're trying to do, is get practical problems. And this is all about word problems, you know what I mean? Practical problems that need to be solved. If you turn it into math, it's a universal. We
Yeah,
can all
math is
get
a
it.
universal language.
Without the language even, we can get it. And so that was so fascinating to me, because people came from all over the world in this program. And so interesting. I was a minority being from this country and being female too, because I was in engineering. But so I was the minority, and but everybody had a different, you know, do you know what I'm saying? It's like, this is a language and we can make this language work. And of course, what we were just talking about a second ago, we have to go with the rules. The rules that everybody understands and everybody accepts. And then we're good. And then we can talk math. What do you say? What do you say? Are you happy with that? Oh dear. I had, I wanted to show you this. Let's see if I can make this so we can. This, they wanted you to find the area. And I know it's not quite as good as it could be, but I wanted to make sure everybody understood how that could be done if you ever see a problem like this. If this little piece was missing, we would have a perfect rectangle. And the formula for area is length times width. So what I'm gonna have to do is, this is 31. I may have to redraw it. So from here to here is 31. From here to here, I have to add them. It's, somebody write this down, 10 and 27 and 13. Okay. So that would be 10 and 27 and 13. That was this way, and then this way was 31. Okay, let me make it so that you can see it. So 10 and 27 and 13, that was across the top. 0, carry a 1, 3, 4, 5, that's 50. Okay, so this much is 50. So I'm going to redraw it. This much, when you add it together, is 50, and this was in feet. This much was labeled as 31 feet. And so if that's all you had, hi Cassidy. Go ahead and talk. So like Cassidy raised her hand. So all you have to do is to go and unmute, and then I can hear you. Let's make sure we got this. Are you there?
I think Cassidy can't hear.
I know.
I can't hear.
No, I can't hear her either anymore.
So that's me.
Oh, there we
Can you
go.
hear me?
I
I
can hear
still
you now.
can't hear. My speakers are all the way up.
Okay, so Cassidy asked to unmute.
Who was just speaking?
I think it was Cassidy. We need to solve this so everybody feels comfortable. And so she raised her hand. So she must have had a question. Can you hear me?
I can hear you.
Let me go back. Something, we've been fooling around here and everything got,
Cassidy is raising her hand.
yeah, let me see what I can do. I'm gonna go back to the meeting. Gosh. Okay, so I think she's doing in chat.
I can hear typing.
I can hear typing. Can you talk, Cassidy? And let's see if we can't solve this. If I can hear the typing, I should be able to hear your voice. While we're waiting, can somebody multiply these two numbers? So it's basically 50 times 31. That's 0, and that's 5, and that's 0, and that's 15. 0, 5, 5, 1. So that's the area of this rectangle, but there was more to it. There was a piece that was part of the bedroom. Let me bring back the picture. There was this extra little section, and this over here is 7, and this over here is 13. So this much was 7 because it said so over here. This much is 13 because it said so over here. So what I need is 7 times 13. And then I'm going to check for my chat. That's 91. So if this is 91 square feet, and this is 1550 square feet, what's the area of the whole house? What do I do? Anybody see? This much was 1550. This was part of the house. And this was 7 by 13.
Just add those together.
Just add them together. So it's 1550. And I'm going to go, and this is 91. This would be square feet. Does that make sense? So you break it up into things that you have formulas for. I have formulas for that rectangle. I have formulas for this rectangle. I need them both, so I added them. Okay, I'm going back to chat and see if I can't solve this problem. Okay, yeah, people were saying about the computer. Ooh, click on your speakers. Still don't know what's wrong. Okay, I'll tell you what I'm going to do is I'm going to, as soon as class is over, I will definitely deal with that. I think what we need to do is I'm going to stop the recording